Gentle people, I want to tell you I'm not a superstitious person. We are set to the sum and product of roots. However, this is the third time I'm recording this video, and something has happened each of the previous two times. In Jamaica, the term is salt. So this video has been an unlucky one, a salt one, but hopefully it's luckier for you than it has been for me. And the idea today, if we can get to do this, I pray nothing happens, is to do the sum and product of roots. And ideally, I want us to be able to look at a quadratic and know the sum and or product of roots just by looking. That's the idea. Now, let's talk about how we'd have been able to previously find the sum or product of roots. Yeah. All right. It's actually writing for the first time. I'm pretty sure if on the first go, this is writing, this is not a good sign. But previously, we'd have to factorize as one method of finding our roots. Yeah, we could factorize. We'd have our binomial product, and then we know our roots, right? So if we factor, then we got x minus something times x minus something else, right? And that's equal to 0. We could say that x would be equal to one root, and x would be equal to another root, and we're good to go, right? Or we could plot our graph, right? Plot the graph for a parabola. And if this is our parabola and we say x times x is x squared, 1x squared, and we know it's a positive coefficient of x squared, which means our parabola is a minimum curve or minima. So I'm going to just do this because I'm lazy. I'm going to do this right here, and I'm going to say that one root is alpha and one root is beta. That's a beta, right? That's the Greek b. We're good to go, right? What else is there? Well, we could solve. We could solve using the quadratic formula. And you guys know the quadratic formula, because the quadratic formula, you have the song. It is x is equal to minus b plus or minus the square root of b squared minus 4ac. That's a all over 2a. You know the song, right? You don't have to memorize this. We had this discussion already, right? So it's not a thing that you need to memorize, but it is something that you come across. So those are three methods. I want us to use today the fourth method. Yeah. So I'm just add a page here, and we're there. And the fourth method, I am butchering this right now, is from Francois Vieti. Right? I think this is a French for it. I don't know if it's Italian or French, to be fair. But the Latin would have been Franciscus Vieta. So some places will have it as Vieta's theorem, or some places will have it as Vieta's theorem. To be fair, we don't care. We just need to know what he's saying. And what Francois says is, given, right, a quadratic ax squared plus bx plus c equals 0 if it has factorization of x minus alpha times x minus beta equal to 0, then we can find, right, we can find an expression for not only the sum of roots but the product of roots just by comparing these two equations. So let me start. The comparison is going to come from this line here. All right, I'm going to divide this through by a, and the reason why I'm dividing by a is because if this is my factorization, then the coefficient of x squared has to be 1, right? Here it's a, and I need it to be 1, so I'm going to divide through by a, and I'll end up with x squared, because a x squared divided by a, right? We can just do this, right? That's my a, no questions asked. You're used to me by now. Plus b over a x plus c over a, right, is equal to 0. That's our first equation, right? Francois is saying, hey, well, this is equal to that other one up here, right? The second equation. So if those two are equal, I could expand this second equation, this one here, and equate it to this one. So let's do that. Let's expand it, right? So let me go. I'm gonna scroll down a bit so you can still see what we have here. So we should be right about here. Now if I expand this one, I take this around this side here, because we can. We say x times x, x squared. We say x times negative beta is negative beta x. Negative alpha times x is negative alpha x. Negative alpha times negative beta is a positive alpha beta, and that is equal to 0. This is still our second equation, right? We can rewrite this, right? If I factor out from this, I can factor out negative. As a matter of fact, I could say this is the same thing as negative alpha plus beta x plus alpha beta equals 0, because I've not only factored out negative 1 from each of these terms. If I factor negative 1 from negative beta x, I get positive beta. If I factor negative 1 from negative alpha x, I get positive alpha. But I can factor out the x as well, right? And I can, if I factor that out, then I have negative alpha plus beta x. Now, do I have to have negative x times alpha plus beta? I could. But if I write it in this format, it's going to be easy for me to compare it to this one here, right? Because now it's I want to say apples and apples. But now I can see the term in x. I see the coefficient of x here. I see the coefficient of x here. Here I see the constant, and here I see the constant. So what Francois was saying is, hey, listen, if that's the case, right, I can say that negative alpha plus beta is equal to b over a. But negative alpha plus beta is a negative sum of roots, because alpha and beta are the roots, right? So I could say alpha plus beta is really equal to negative b over a. That's my sum of roots, right? And then I could say alpha beta is equal to c over a, and that's my product of roots. When I say salt, so far we're doing well. We're getting somewhere. We're making some progress. So this is what Francois was saying. This is my sum of roots. This is my product of roots, and I can read that from any quadratic whose coefficient, well, to be fair, I can read it from any quadratic whose coefficient of x squared is 1. So what does that look like in practice? All right, we're going to do 2 examples of this, and what I will probably do for the next video is just a video of all exam questions on this topic. A quick one. This is a good topic. It shows another way that you can read information off from a quadratic, and that's super important. So here's our first example. I'll likely also post a worksheet on this, because this is light work for you guys. But I've written this down, and it is now dark and I can't see, but we will press on. We'll find a way. So the quadratic, as I can barely see it, is x squared minus 7x plus 10 is equal to 0. I believe it and you believe it. Yeah, all right. I might be able to make it to the next one with a light. All right, so here we are. No. Let's go the long way first, right? Some people would like to get straight to the answer. I want us to go the long way first. So let's go old school. Let's go factorization. We're not graphing anything on this, I promise, right? So if I'm factorizing, I know my first term times my last term. My term in x squared times my constant at the end gives me 10x squared, right? So I say, okay, I get 10x squared, but I need factors of 10x squared that sum to negative 7x. Now, by now, you are all, specialists at this, professionals, right? This is light work for you. So I know negative 5x times negative 2x is going to give me a positive 10x squared, but it's also going to sum to negative 7x in the middle right here. So instead of having this, I could just write x squared minus 5x minus 2x plus 10 is equal to 0, because you're a star. And now we're going to factorize those first 2 terms. So factorizing 2 at a time. What's common to these 2? It's going to be x. I'm going to factor that out. When we factor that out, we get left with x minus 5, and we must get this bracket back. So I'm writing my x minus 5 right back over here. And then all I have to do is ask myself, what times x gives me negative 2x? It's negative 2. Light work. What's common to these 2 terms? X minus 5. We get left with x minus 2 is equal to 0. And so our roots, therefore, roots, writing all of these statements. Look at you. X minus 5 is equal to 0, or x minus 2 is equal to 0. And what can we say now? We can say x is equal to 5, that's one root, or x is equal to 2. Both of those values make this equation work, right? Make the left-hand side equal to 0. Everybody's on the same page? If that's the case, I talk in at this point like we're all in the same classroom, but this is by reflex. All right, so we'll have our roots, right? Cool. What's my sum of roots? Well, sum of roots is as the name suggests, right? 5 plus 2, light work. Product of roots, yeah? 5 times 2. If you're getting this wrong, don't say it out loud. All right, nobody has to know. All right, so we're good. Now, what would Francois have done? Francois would have said, yo, you did a whole lot there. You're doing way too much. Too much work. Now, I should, by right, go look on the paper where I wrote this down, but I cannot see it. So it's minus 7x plus 10. All right, so let's put this here. Francois now, right? Viete theorem. If we want, we can call it that, right? We said x squared minus 7x plus 10 is equal to 0. What did Viete say? Viete said, look, remember sum of roots would have been equal to minus b over a. Well, that would be minus 7 over, oops, it's not minus 7, you know, it's minus 7. Let me erase that. Dun, dun, dun. I can do it. Let me put it, let me make some space right here. All right, that's better. All right, so it would have been minus b over a, which in this case is minus, or minus negative 7 over, what is a? 1, which means that this is just 7, right? Product of roots would have just been, what the last term would have been c over a, right? But c is what? 10 over 1, which is just 10. So what we've done here is essentially the same thing with less steps. We found the sum of roots here by factorization. We got it to be 7, we got it to be 10. But we saw that Viete's theorem literally says that, hey, the sum of roots is minus b over a. And in our case, a is 1. So in that case, it's going to be minus 7 or plus 7. And the product of roots is just going to be c over a, which is 10 over 1, which is just 10. It's way quicker. It's a matter of seconds as opposed to having to do the factorization. All right, one more example and we're calling it a night. Example 2. All right, showing off over here because I cannot see, I promise. This is 2x squared. Now you have no idea, but it is very dark because I have yet to turn the light on. So I am doing my best sighted impression, right? So I have 2x squared minus 5x minus 3. I'm going to use the factorization method. All right, if I'm factoring, I'm going to take the first term, multiply it by the last term. I'm going to end up with what looks like negative 6x squared. And I want for this to sum to 5x. So I could use 6x times negative x. And when I rewrite this, it becomes 2x squared plus 6x minus x minus 3 is equal to 0. All right, this is light work for you. So let's factor. What's common here? 2x in both of these terms. Factor 2x out, I get left with x plus 3. I need my bracket back. Write my x plus 3 over here. Right? What times x gives me negative x? It's going to be negative 1. And when I factor completely, I get x plus 3, because that's what's common to both terms, times 2x minus 1 is equal to 0. All right, that means roots wise, right, x plus 3 is 0, or 2x minus 1 is 0, which means x is equal to negative 3, or 2x is equal to 1, x is equal to half. Now, if that's the case, and you see how much writing we'll have to do just by factorizing, Viete's method is way quicker, right? That means our sum of roots is simply going to be -3 plus a half. And I can look at this as -6/2 plus a half, or -5/2. And then my product of roots would have been -3/1 times 1/2, or -3/2. Bear that in mind. Keep it in mind, right? Because you're going with Vieta's method now, right? So, according to Vieta, right? I have said Vieta, I've said Vieta. Sum and product of roots is all you have to say. Again, I'm doing a bit too much. All right. It was 2x squared plus 6x. Nope, 2x squared plus 5x minus 3 equals 0. I'm pretty sure. I am not 100%, but I look back. All right, so we're good. All right, so let's use the method now. I just need to write this as a term where the coefficient of x squared is 1. So I'm going to have x squared plus 5/2x minus 3/2 is equal to 0. And I can just read now my sum and product of roots off, right? Here, my sum of roots is going to be equal to, it's going to be, if I need it to be, the negative of 5/2, and my product of roots is going to be -3/2. Does that coincide with what we had before when we factored? Let's check. Pretty sure it did. There we go, all in one line. So this method works. It is pretty quick, it's pretty simple. Again, I am going to, for the next video, just do exam questions on this, so that you can get some practice, see what the questions look like. How can they be made to look a little bit different to what you're used to, a little bit more complex than what this is. And I will definitely post a worksheet on this. Again, don't forget to like and subscribe. Thank you for bearing with me. This has been a difficult video to put out because things have been happening all day, but happy that you stuck around, and looking forward to the next one.